It's always good to revise the fundamentals of sorting. So in this video, we're going to talk about merge sort. Merge sort works by divide and conquer. Given a source array, you are dividing the array into two subarrays, a left subarray and a right subarray. Divide the subarray all the way until it reaches the length of 1 or less. This should be a recursive process. And after your left subarray finish recursion and your right subarray finish recursion, you expect your left subarray and right subarray to be sorted on their own. Then you merge them so that your total array is sorted. Something to note is that when you are dividing the array, you're not actually dividing the physical array. You are dividing the array logically. So you are not sending down the copies of a subarray. Instead, you are sending down the index of the start of the left subarray and the start index of the right subarray. The reason is it is expensive to create array copies. Now let us walk through the call stack. We should divide the array into left and right, so we should split at the middle. If our low index is 0, our high index is, let's say we are working on the assumption that our high index is exclusive. So our high index is actually 5. Then our middle will be 0 plus 5 over 2, which is 2. So we split into left and right. So for our left branch, the low should be from 0 to 2. For the right branch, it should be from 2 to 5. And in our left branch, we are going to have 5, 2 as the subarray. And now in our right branch, we are going to have 6, 3, 1. Do bear in mind that 5, 2 is only a view of our original array. We are not creating physical copies. If you use Golang, slice in Golang is the view of the original underlying array. The view itself does not hold actual data. In our recursion, we are only sending down the index, so there's no physical copy. Now, just to be precise, because our left subbranch has not finished recursion yet, so our right subbranch has not started, so let's erase the right subbranch. So let's keep going. 0 and 2, we should split again. Our low is 0, high is 2, middle is 1. Left subbranch will have 0 and 1. Right subbranch is 1 and 2. The view of the left subbranch is 5. The right has not started yet, but you get what I mean. Because the length of the array is 1, so we can return straight away. Then we go on the right side. The low and high will be 1 and 2. The view of the right subbranch will be 2. Because the length is 1, there's nothing else for us to do. You cannot split any further. You go back. From the point of view of this call stack, you have already collected the results of your left child and your right child. And your left child is sorted on its own, and your right child is sorted on its own. So you should operate on these two and make sure the total array is sorted. By total, I only mean from index 0 to 2. So this is the merge step. In the merge step, we will need a temporary array. But we'll talk about that later. But let's just assume after the merge step, we have successfully made it to 5. So from the point of view of this call stack, you have finished the left subchild, so let us go on the right child. Your right child will have the low and high of 2 and 5. The view of the right child is 6, 3, 1. You should split at the middle. But what is the middle? Low is 2, high is 5, middle is 3. So you split your left child will be from 2 to 3, right will be from 3 to 5. Of course, right has not started, so let's not do that. 2 to 3, the view is only 6, so you return. Then we go on the right side. Right side is 3 to 5, so the view is 3, 1. You need to split again, so on your left, well, the middle is 4, so your left will be 3 to 4. The view is only 3, nothing else to do. You return, go on the right side, 4 to 5, the view is 1, come back. After a merge step, your 3, 1 will become 1, 3. Then from 1, 3, you come back to the original call stack. Of course, this is already 1, 3. So 6 is the left subarray, 1, 3 is the right subarray. After the merge step, you will have 1, 3, 6. Then you return. From the point of view of this call stack, of the top level call stack, after both your left child and your right child has finished recursion, your view should be 2, 5 as your left subarray and 1, 3, 6 as your right subarray. So now is a good time that we discuss how to do merging. When you're doing merging, you already have the guarantee that the left subarray and the right subarray are sorted on their own. You know the starting index of your left subarray, which is 0. So L is 0. It doesn't have to be 0. It just happens to be 0 because we are examining this call stack. If we are examining this call stack, then this 1, 3, 6, then the starting index of the left subarray will be 2. Now the starting index of the right subarray is 2. Now we also know the starting index of our total view. From the point of view of the view, the low is 0, high is 5. We will need a temporary slice. So this is our temporary slice. And we will make our temporary slice the eventual sorted array, the final product. So you just keep moving pointer of our left and our right. So because right is less than left, our temporary slice have 1 as the first number, then we increment right. Because our left is smaller than the right, so 2 will be the second number. Then we increment left. 5 is greater than 3, so we increment right. Now 5 is less than 6, so 5. Now you realize your left subarray has already out of bound. So you know whatever that is left over on the right side should just go into the temporary slice. So our temporary slice will have 6. Our temporary slice is the sorted array. So you can just copy over everything inside the temporary slice and override your original array. So let us code it out. We need a temporary array. Let us call it temp with exactly the same size as the original array. We need to have a helper function. Let us just call it split. The split is not going to return anything. We should pass in original array, the temporary array, and the low and the high. So our high is going to be the size. I made the decision to make the high index exclusive. Now this is a decision that I make. You don't have to follow. Then eventually we return nums. So we will keep overriding nums. And again, low and high is the range of our view. Low is inclusive range and high is the exclusive range. Now if your array only have one element or less, we will just return it. So high minus low less than 2, we will not do anything. Then we should split. So we should split at the middle. So what is the middle? Middle is low plus high over 2. We should split low and medium and medium and high. Because on our left side, M is exclusive, so your M should be inclusive on your right side. Then let us do merging. To do merging, we need a left pointer for our left slice. So L, we can just start from low. And our right pointer will start from medium. And we will keep moving the smallest element into the temporary slice. We will do this for this number of times. So this is the number of times that we are going to do this. So let us see when your left side is smaller. If my right side is out of bound, definitely I should take from my left. So when does your right side out of bound? When R equals to high, right? Because high is exclusive. So once it touches high, your right side is out of bound. Or your left side is smaller. So if my left side is smaller, my left cannot be out of bound, and my left side is smaller or smaller than equal. You should take from your right, you should take from your left. So your temp I is num's left. Else you take from your right. After this merging, you will need to copy over everything from your temporary and override it in nums. So you can do copy from from low to high, and copy over to nums. So copy takes in 3 arguments. The first argument is the start of the source array. The second element is the end of the source array. And the third argument is the destination array. So the source is from low to high of our temporary array, and we will copy over to the destination, which is nums. Let's see if it works. We can do a slight optimization. If the first element of your right side is greater or equal to the last element of the left side, then you don't need to merge. This is the first element of your right side, and this is the last element of your left side. If your right start is greater than equal to your left end, then you don't need to adjust the positions. So there we go.